What if the mountains you see were born in sinking seas? For decades, geology said yes. The geosynclinal theory imagined vast troughs in Earth's crust quietly subsiding, collecting oceans of sand and mud, then somehow squeezing upward into Alps and Himalayas. Elegant story, beautiful diagrams, very 19th century. The idea promised order in a messy planet. Mountains were just sediments that changed their minds and went vertical. Here's the setup. Picture a long, slowly sinking basin along a continental edge. Rivers dump sediment. The pile grows kilometers thick. The weight keeps the basin subsiding, and everyone is happy because the math balances. Then, after a long geological nap, the basin gets compressed. Layers buckle, fold, fault, and boom, you have a mountain belt. If you're a textbook in 1910, this is a mic drop. And to be fair, it fit observations. Thick folded strata? Check. Marine fossils high in ranges? Check. Heat and pressure making new rocks? Check. A theory doesn't need to be true to be useful. It just needs to be useful until something truer shows up. But then, the evidence started heckling. The ocean floors weren't quiet dumping grounds. They were young, ridge-centered factories. Paleomagnetism drew zebra stripes across the seabed, showing its spreads. Deep earthquakes traced slanted scars into the mantle, marking subduction. Continents fit together like a divorce that never finalized. None of this plays well with passive basins magically crumpling on schedule. Geosynclines assumed vertical motions and Earth cooling and wrinkling. Plate tectonics brought moving edges, real forces, measurable speeds. You don't need a basin to politely sink for 100 million years when two plates can collide and push rock 100 kilometers sideways. Folds, faults, metamorphism, magmas, mountain belts. Suddenly they all share one engine. Plates converge, one dives, the other deforms. The world stops shrugging and starts driving. So why did geosynclines last so long? Because they explained just enough, and we're suckers for tidy pictures. Also, data were scarce. No satellites, no global seismology networks, no magnetic stripes. If you only see layers and fossils, a sinking basin is a reasonable ghost to blame. The punchline is not that old scientists were foolish. It's that science is brave enough to retire great ideas. The geosynclinal theory built a scaffolding for mountain thinking. Then plate tectonics knocked it down and kept the bricks. Modern geology still loves basins, subsidence, and thick sediment piles. We just put them inside a larger machine that actually moves. Next time you stare at a mountain, don't imagine a sleepy trench becoming a crumpled cake. Picture plates grinding, slabs diving, continents colliding, and rocks that traveled from seafloor to sky by ride-sharing with physics. The beautiful wrong idea had its moment. The planet, predictably, had other plans.